My name is Simon Riggs. I'm a Postgres Fellow at EDB, and I'm one of the authors of the merge command in Postgres 15. So first off, I wanted to draw your attention to this remarkable graphic where we have the Postgres elephant actually being larger than the Brooklyn Bridge. And I think that's really an important graphic because it's actually conveying how big Postgres is now and how things have changed over the years. So I really like that graphic. And the merge command is one part of the growth of Postgres. As we mentioned in the last talk, Postgres does not have every feature that it needs. And I'd gone on record as saying that we've got another 20 years of development ahead of us to make Postgres brilliant, according to me, okay? Because I've got high standards, as have the rest of the Postgres development community. And that's why things really take quite a long time to get into Postgres. But it's only a long time in a scheme of years, okay? That's not really a long time in terms of the market. So what I'm going to do is start off by talking a little bit about the SQL Standard and Postgres, and then I'm going to talk in more detail about the merge command itself. So back in the day, SQL 92 was 30 years ago, and when that came out, everybody saw that it was a sort of dramatic change, that we would be moving towards a standard database language rather than what we'd had before was a sort of mishmash of approaches. But the standard at that time was incomplete, and one of the things that it lacked was an atomic action that would do either an insert or an update depending on the current contents of the database. So this was a very strange omission from the original SQL standard, but I guess it's an understandable one because introducing a standard like that was a very forward-thinking action at that time. So I forgive the guys for having an incomplete view of what SQL should be, but it did leave us with a bit of a gap. And what that meant is that we got various implementation-specific approaches. For example, MySQL's got insert on duplicate key update. SQLite has got insert or replace, and other databases like Teradata had other approaches to upsert as well. And you see the same thing occurring in NoSQL databases where the feature exists, but it's not necessarily called the same thing as upsert. So that meant also that Postgres came up with its own approach and its own syntax. And we have something called insert on conflict update. And that was developed because one of the things that we didn't yet have was a clear specification of what the concurrent behavior should look like. And the insert on conflict was developed with a viewpoint that what we needed was a principled approach to how this command would work. And therefore, we developed at that time something that used locks to ensure a very specific outcome from the concurrent execution. Now, obviously, where that leaves us is we've got a very cool command that does something very useful, but it doesn't follow the standard. And what we've seen all the way through the development of Postgres is that we follow standards. One thing, because we respect other people, we respect people from other groups, but also standards give us a way forwards, a well-defined path to develop software. And so that makes it actually easier for us. So although insert on conflict update exists and it works perfectly fine, it didn't follow the standard. And so that's where we go back to the SQL standard and we see that in 2003 there was a thing called a merge command added, And then in a later update, in the 2008 update of the standard, there were some extensions to that standard to make it more usable in practice. But one of the criticisms of merge is that it actually enforces the status of each row only once, and that does cause potential problems with concurrent usage, which are not felt by the insert on conflict command. So there are some differences between what merge is according to the standard and our previous insert on conflict. So we did at first start the development along the lines of, let's make it like insert on conflict, but with just syntax changes. And actually, what we discovered was that the community wanted it a different way. So what we now have in Postgres 15, which is due to be coming out in the next couple of weeks, is a fully working merge command. So I'll explain how that works, and I'll explain some of the things it doesn't yet do. So there's a few minor extensions that we might expect in the future. But the big missing slide really is actually to talk about how the development of this command worked. Because actually I first started talking about implementing it back in 2009. And a number of people had some attempts at making it work, but as typically happens in the community, somebody will propose something, and then when we zoom in and look at the detail of the patch that's been proposed, it turns out that the patches were not good enough and that they had certain faults within them that needed to be corrected. And so actually it took a number of different conceptual developments over a number of years so that we talked about how we would like to see it. And then a few years ago, back in 2017, I was able to get the funding to commence the finishing of the merge project. And so by 2018, we actually had what we thought was a fully working version. Obviously, what the community does is pull things apart, have a look at them, and see if that's the right way that we want to implement it. And in that case, the 2018 version didn't make it into Postgres, but in essence, the main body of that patch was what was eventually used by Álvaro last year to finally commit it to the Postgres source code so that we would have this available to us in Postgres 15. Okay, so a little bit of history, but just to say that these things are not just a simple matter of let's sort of rush out a couple of lines of code. It does take a significant amount of effort. Now the effort comes through to us as quality, okay? So it's easy to do something, it's hard to do something well, okay? And especially when the community process involves so many people over a large period of time, multiple time zones, and a mailing list, right? So those things take time, and we must respect that process, okay? So what is merge and what does it look like? Well, as you might expect, the merge command starts with the word merge, okay? So that indicates that this is a whole new statement within the SQL standard, and what we specify first is the target table. So we say merge into table name using a data source, which in this case is the recent transactions table. So we're going to merge data into customer account table, and we're using a source of data as recent transactions. Now merge recognizes that we might be doing some updates, so we need to work out a way of identifying the updates. So what we need is actually a join between the source and the target, and that's specified in the third line where we have the on command, and that's where we specify the way that those two tables are joined together for us to search for updates. And then after that, we have a number of different clauses that specify what the behavior of the command is going to be. So if when we join the source and the target together, we find that there is a match, then we will perform an update. If there is not a match between the source and the target, then we're going to perform an insert, okay? Or more specifically, we will execute when matched, then, and then we will execute that particular command. When not matched, we will execute the second command. Now, the ordering of the when matched or when not matched doesn't matter, okay? In fact, you're not even constrained. You don't need to have both. You might just have when matched or when not matched, okay? But it doesn't actually matter which one comes first, because that's irrelevant. What I'm saying that we do when we look at the execution of the statement is we decide whether a particular row in the source matches or does not match, and then that triggers the specific statement to come through. But notice that there's differences in syntax. On the update, for the full strength update command, we would have a where clause. In this syntax, there isn't a where clause because we are already identifying the row. And the same on the insert statement, there's a couple of differences, one of which is that there's no into keyword on the actual insert statement. So that's the rough shape of merge, and what I'm going to do now is talk to you all about the very small details that relates to how it executes, how it's optimized, and various other details. So the execution of this is rather straightforward. We get the source data from, in my diagram there, the table on the right is recent transactions, and we take the data from the target, which is the data at the top in my diagram, and we're going to merge those two things together according to the specification of the join. So in my example here, I've got rows 1 and 2 in the table that's already there, and we've got incoming from the source values 2 and 3. And obviously, I've chosen a very simple example so that you can see by that data that the value 1 does not match, the value 2 does match between the source and the target, and the value 3 does not match, okay? And so you can see that the actual outcome that we would get from this, according to the SQL statement on the left, is that the value 1 comes through with a balance of 10, because there was nothing matched here. The customer ID 2 has 10 from the existing data plus 5 from the incoming data, giving us a total of 15, and that's matched. And then the value 3 only exists in the source, and so we have the value 10. Okay? So I hope that simple example gives you all you need to know about the way that the merge command works. So if I can summarize what you've just seen, merge is a set-based command, so that you specify a whole set of changes to apply from the source through to a target table. Okay? So it's a very powerful command. Now, one of the things I noticed when I looked at this command is it does look a little bit like some kind of old COBOL program where we're actually sort of thinking about things in terms of batch orientation. Now that might be the source, but I don't actually definitely know. I'm just saying it looks a little bit like an old COBOL program. So the source of the merge can be a table, a view, or a query. We can do a self-merge from a table into itself. I can't really think of a good use for that, but it is actually possible. We've managed to support the with clause, which is useful, but we don't support with recursive. And it doesn't matter whether you put the when matched or when not matched first. The command is identical no matter which order you put those two things in. So let's say a couple of fairly obvious points. If there's no rows in the source, then nothing happens, okay? So that's kind of just to confirm what hopefully you would be expecting. The source could be a temporary table, and obviously the target can be a temporary table as well. What's very specific about the syntax for this is that you can't have insert when matched, and you can't have update in the when not matched clause. So the commands have to be related to the matching that works for that. Now, one of the big things that we had sort of arguments about in 2009 was whether merge would support rules, and it's almost impossible for it to support rules in the way that they are defined within Postgres, certainly with the way that they are implemented, and those concepts really don't mix at all. So if there are rules defined on a table, then you won't be able to use the merge command because there's no real conceptual mapping between those two things. So what's not supported in merge yet is that the target can't yet be an updatable view, it can't be a materialized view or a foreign table. There's quite a lot of tricky complexity in each of those three for various reasons, but I foresee that they will be fixed in the long run. There's no returning clause yet with a merge, and I do think that that is implementable, but it hasn't been done yet. And the last thing is with recursive. I'm not clear how that would actually work or whether it would be possible. So I'll just say it might never be implemented. But again, I don't see that as a particularly important point that we need to care about. So let's talk about some more aspects of merge from a perspective of conditional execution. The 2008 standard introduced conditional when clauses, and these are implemented by saying and then a condition. So it has to be the word and. You can't say or in that particular place. So you can say and then an expression, and in the when matched or when not matched, you can only specify conditions based on data that come from the source. You can specify functions in there that are volatile, but that's not supposed to happen according to the standard, and obviously you might get some rather strange outcome if you say when not matched and rand greater than 0.5. You can write it, but it's pretty weird, and I can't see a reason for that. So basically, the conditions that you specify are based on the data. Now, if you've got a when matched clause, then you can specify conditions that come from either the source or the target or both, as in that particular example. And you can see how this is working. If it's not matched, then we do an insert. If it is matched and the stock level that remains in the table is greater than 0, we perform an update. Or if the stock level drops to 0, we're choosing in this particular data model to actually delete that row out of the table completely when the stock falls to 0 or below. You might choose to keep it in there yourself, but again, this is just an example of something that you might wish to do. Now, when we have multiple conditional rows, we try to match them in the order that they are specified. So where it says when matched and that first test will always be attempted before the next row. And in fact, you can see that's good because the second when matched clause is not conditional. So we have a first row that's conditional and then a second one that will always succeed if it gets there. Okay, so when you execute this, you might find that the when match then delete never gets actually executed in that particular merge command. It's all based upon the data. Okay, so depending on the source data, some of those clauses might or might not be executed. Now, what you're probably thinking at this point is it would be really nice if we had a way of telling how many rows were matched by each part of the merge command, but actually we haven't got that in the output. So what you can do is you can actually program that in yourself by having a source reason column on your table, and then you can use the merge commands to say this row was affected by the third command and things like that. Okay, so that's one way of working out what's actually happening in a complex merge command. So this is pretty simple stuff, but you can imagine in more complex examples that we might end up with like 1,000 lines of complex merge statement in some situations. So because things do get complex and because there is no else statement, it makes sense to have a sort of self-documenting program, and that's why we've added the do nothing clause. So this is an extension to the standard, but it's something that DB2 had, and it's something that was at one point under discussion for the standard, but we thought it made sense to add because it makes the program that is contained in the merge statement actually more readable thing to have. Obviously, the do nothing statement doesn't do anything, so it's not like a huge departure from the standard in terms of concurrent execution. So let's have a look at the particular usage rules again. Let's be clear that only one when clause will fire for each row. And once that when clause has executed, further when clauses are not even attempted. So if there's some byproduct of the execution in later parts of the statement, then that will never happen at all. Now, in some cases, it's possible to write a merge statement that will have provably unreachable clauses within it. Now, if we spot that, there is something that will throw an error saying this merge command has got something within it that is completely unreachable, and so that we're going to call that an error. Okay. It is, however, possible to program things in a way that things are literally unreachable, but that's based on the data. Okay. So what you might find is there's a sort of rarely executing part of your merge clause. So obviously, in terms of testing, when you've got test data, you need to have a test for each when clause in there and check that it's actually working. So the merge conditions aren't supposed to be writable, but there isn't a check for that. What I'm talking about writable is where you would use a function, and that function actually did something like inserted or updated data in other tables. That would be pretty weird to do that, but there isn't actually a check to stop that occurring, okay? Which is generally the way that Postgres works anyway, is that there's no knowledge or prevention of what happens inside functions that get called. In terms of concurrency, the status of matched or not matched is set once. And so if there is some concurrent activity on a table where we check that there's a match, and then concurrent with the execution of merge, someone then immediately deletes that after we've decided that there's a match, and then we go to update the row, it's possible that we can get some kind of a concurrent error. So it's there's basically two kinds of error that you can get. You can get a duplicate key violation because of concurrent actions, or we can see that a tuple has been locked by somebody else, which will throw an error. So what that means, though, is that obviously the error will completely roll back all of the changes that were made by the whole merge statement, and you can then re-execute the merge statement again. Okay, so re-execution will not cause multiple updates to take place because the merge rolled back everything. So there are no save points through the execution of the merge. It doesn't do the first 100 and then save the batch and then continue. It's all or nothing. It's an atomic command. So all of the changes or none of the changes. Okay. So a slight comparison then between the way that merge works and the way that insert on conflict works. So they are not completely interchangeable. Insert on conflict does deal with the concurrent usage scenarios. Merge does not. Now, the merge in the SQL standard does not specify how the concurrent behavior should work. So we've made some decisions about how it works, but the main point is that the status of matched or not matched is only decided once at the beginning of the command before it begins executing all of the changes. Another difference, obviously, that comes out of that is that because insert on conflict uses locking to ensure its concurrent behavior, there is a greater overhead in the execution of that command. So these two things are not interchangeable. So in terms of other details, what I'm going to do now is talk about the way that the joins work, talk about the way that the optimization works. So when we're joining the source and the target, we have the concepts of it being matched and it being not matched. And what that means is that in order to get that to work, we need to execute an outer join, in fact, a left outer join from the source onto the target. And we've optimized that to say that if there are no not matched clauses in your merge statement, then it will just do an inner join because it can see that it doesn't actually need to do an outer join. Now that might make a difference in the speed of processing. It might not, but the optimization of outer joins is more complex and sometimes results in a slower execution plan. So that might be of interest to you as an optimization. Second point is that each target row can be modified only once, which means if you've got duplicates in the source data, that might lead to a situation where you're trying to update the rows more than once. So the implication of that is that the key of the data source should match the key of the target. Now that is not actually enforced, it's not a requirement, but if it isn't true, then you open yourself up to the possibility of an error. Okay? Now there might be reasons why you didn't want to do that, but we don't require it at the start of the merge command. We just detect if it's actually happened and it will reject that with an error. Okay? So you are warned. Okay, so let's look again at how the execution of the merge command works. This slide, before you're reading it and going, I've seen this slide before. Yes, it is exactly the same slide. Okay, what I've done here is just thrown up that slide again, just to remind you of the execution example that I gave before. And then what I'm going to do is explain, literally explain that merge command so that you can see what comes out the other side. Now, how do you know that this explain is for a merge command? Well, it's got the keyword merge at the top there. You can see we're going to merge into the target, and this information here is the relevant information that relates to how the merge command executes. You'll see that it has a summary. Because there is no delete there, it hasn't mentioned delete. If there were some deletes, it would say so many inserted, so many updated, so many deletes, okay? But it doesn't tell you at that point which when clause was executed so many times, okay? There's potential for that to happen, but that's not the way that we've chosen to do it up to now. The rest of the explain is showing you what happens when you join the source and the target together. And you'll also see the word merge there. So it's doing a merge left join. Now, that is pretty confusing because what's actually happening there is we're using the same word merge twice for two different concepts that are completely unrelated, okay? So the fact that it's doing a merge join is nothing to do with the merge statement, okay? So it's not like we invented a new kind of join specifically for merge. Merge join already existed. What we're saying is that the merge statement, when optimized, is choosing to use a merge join, okay? And that's just a sort of unfortunate coincidence. So there's nothing specific about the merge statement that forces you to use a merge join. In fact, you can use any kind of join in order to get the job done. So the indexed access is completely and easily possible with the merge statement. And as a result, merge is very suitable for OLTP, fast actions. So you might think, well, hang on, that's not very suitable to OLTP because you've got like the source is a table. But remember what that actually means. You can have a table that has just one row in it, or you can use the values clause to specify a single row table as source for the merge statement. So it is optimized for OLTP. That was one of the very important aspects that we worked on, was to make sure that it was extremely valuable for OLTP, but it's also valuable for large batch execution, as you might get in a sort of typical data warehouse update. And so the merge statement is optimized in both directions, in that partitioning works with it, and so it can easily be used for large databases, and it can also be used for OLTP, okay? So we've gone to some trouble to design it correctly so that the optimization just works in a number of cases, okay? But please don't be thrown by the dual use of the word merge, because obviously that can be confusing. So just to mention some other points, privileges for the merge command are based on what you've written in the when clauses. So if you've mentioned an insert and an update, you will require both of those privileges before execution begins, even if the update statement is never executed in that particular execution, okay? Because you've specified it might update, it will require you to have the update privilege and the insert privilege. And obviously if you specify delete, then there'll be a check on that privilege as well. So it doesn't matter what's executed, it's based upon what you request. And then finally, to talk about the way that merge works in terms of triggers. So a row trigger will fire for each and every action. The triggers fire in the order that it processes the rows. So in this particular example, it will execute some before triggers and then some after triggers. So the rows in this example, 30, 220, 440, are based on the order of execution for the data. Okay, so if there was a different plan with a different ordering, then it would fire the triggers in a different order. Okay. But for one particular set of data, it will always execute in the same order. With regard to statement level triggers, they also execute. but obviously they will execute not depending on the presence of data or the absence. It's basically if you specify an update or a delete clause somewhere within your merge command, then the update statement trigger will fire. Okay? It doesn't matter that no rows are updated. It's just simply the specification of the update that causes the statement level trigger to fire. And one undocumented point is that the statement level triggers always fire in that order. So it always fires inserts, updates, then deletes, and for after triggers, it does them in the opposite order. So delete, update, insert, okay? So there is a consistent way that we execute triggers, and everything is fully supported. What we should say as well is that transition tables are supported so that you can actually collect all of the changes that have been made from the merge command into the transition table, and then you can use that to execute further commands. And it's a shame that we've not yet made it work for materialized views, because obviously this is a perfect case where we could use the changes coming out of the merge command to update a materialized view. Okay, so that's one change that we would hope to see in the future. I'm not sure that particular change is excessively hard, but we didn't approach it. Okay, so I've told you everything about the merge command. What I would like to do in a minute is just sort of go back and sort of make a few other comments, conclusions. But questions at this stage? Any questions on the way that the merge command works, or in fact any questions at all? So.
First, thank you very much for implementing this. This was a dearly missed piece of functionality.
Thank you.
My interest is very selfish because I'm involved with the Babelfish project for Postgres.
Okay.
SQL Server has a when not matched by source clause, which I understand is missing here because you said if the source table is empty, there's no action.
Yeah, I mean, I've no idea what SQL Server does, so I can't really comment. We've followed the standard, and I presume SQL Server has not. So.
That's right.
Yeah. What are you asking?
Well, so basically with the SQL Server, if the target table has rows that do not match anything from the source table or the source join, right? Then you can do an update or a delete clause. And I'm just thinking out loud here, like how can I fake that in Postgres when it doesn't support that model?
Well, I mean, Postgres does support matching and not matching. Yeah, that's there. So it might be some aspect of syntax that's missing, but I can't really comment on what SQL Server does.
So when not matched by source, then delete. Basically, I will delete rows from my target table that were not in the source. That's
okay.
What
That's
I can do.
Weird. Don't know.
Okay.
Yeah, I mean it's possible. I think the framework. Yeah, I mean I don't see any barriers to that particular implementation. Any other questions about Postgres?
Hi. So I wanted to ask what kind of locks are required on the source and target tables?
It'll be the same, is it row exclusive lock? The normal level of locking that's taken by DML commands. So it's only a table level lock that's taken. It doesn't apply row level locking. And obviously, but once a row is updated, it will effectively be locked by the transaction making the change. But we don't use row level read locks while we are determining what's happening to a particular row. So if you look at insert on conflict, what it does is it literally locks a row and then it decides what's going to happen to that row and then it unlocks it again. Okay, so we're not doing that because that's not required by the standard. So the avoidance of locking is going to make the merge command a lot faster on larger batches. So.
And is there a consideration of doing some batch updates or batch inserts in this? Because it seems rather slow to have those insertions sequentially in that sense.
I didn't hear enough of what you said to process it. I'm sorry.
So I'm asking whether there is a possibility or whether it does some batch inserts during the process, or does it perform that one by one?
Yeah, well, so we're not using like a bulk insert object internally within the code. I mean, it could be done, but there isn't. That would only work for inserts anyway, but there's no concept of a bulk update within Postgres at this point in time. There might be in the future, and in which case it could be optimized like that. But no, it does process it row by row. So, yep.
Are there any plans to add a returning clause?
There are no plans, but I think it's easily possible. Yeah, I don't see any barriers to it doing that, but I'm not sure what the standard says on it in particular. So
the standard does define what should be in the
okay, yeah.
table data change.
So I mean, you know, where we are now is I'm really happy that the merge command is finally in Postgres. It's taken a lot of effort over a number of years, and what I wanted to do was to say thank you to the many people that worked on it, but obviously certain key people. Pavan did the more complex parts, got this over the edge. I did a lot of the laborious process stuff and wrote like tests and docs for everything and kind of got that into the right state. Amit made some aspects of partitioning work correctly, and Álvaro was the final committer of the command. So he reworked the placement of the optimization and rejiggered the way that the executor was rewritten, because we had to rewrite the whole executor in order to get a rather complex way that merge executes actually into Postgres. So thank you to those guys for doing that work. So my conclusion here was in fact really a very similar one to Vic's, but it was obviously a chance placement of the two talks being the same. Postgres respects standards, and what that means is that as standards change over time, we will implement those things directly into Postgres. But that is not just the SQL standard. What's known as the SQL standard is actually the data access standard produced by an ISO working group. So it's not about SQL as a language, it's just about data access standards. If there are more data access standards in the future, Postgres will move towards implementing them. But really, if you look at what Postgres does, all of the way across the board, we respect standards in the way that things work. So we follow standards like IANA numbering, IEEE approaches to floating point numbers. There's a lot of the IETF standards built in, and even, you know, God help us, there are actually JSON standards that exist, and they're implemented by Postgres as well. And things like the way that time zones work and dates and such like, we follow everything as far as we can to international standards. So what you get here is it's a database produced by a group of people, but the thinking behind Postgres is actually tapping on the huge pool of other technical standards that are built up by experts in their field. And I think this is a very important point, because by respecting those standards, we're drawing on that expertise into Postgres, not just kind of making stuff up on our own all the time, which is a really bad way to progress. So, merge is in the SQL Standard. It's now in Postgres 15, and this is one more reason to migrate away from those other databases and begin adopting Postgres. So I encourage everybody to take the word out and tell people that Postgres is now even better and that we will be following other standards in the future. Okay, so thank you very much. If there's any questions,
Last chance. I think that's it.